Two speakers separated by a distance 5.51 meter are driven in a phase by same amplifier. A listener is located at point A. A distance L is 3.11 meter directly in front of one of the speakers. What is the lowest frequency for which there is a maximum signal at A due to constructive interference? The speed of sound is given. Okay, so before starting, first let's write down a few equations, okay? The first equation will be for the constructive interference. For the constructive interference, what we have path difference, delta L, is equal to the m lambda. Okay, it's constructive. For the destructive interference, we have path difference, which is equal to the m plus 1/2 lambda. Okay. So in the first question, it says what? It says that what is the lowest frequency? The lowest frequency in the part A, the lowest frequency for which there's a maximum signal at A. So maximum signal at A due to the constructive interference. So we're going to use the first equation, okay? So before that, so what is the formula? So we have the frequency is equal to the V over lambda, right? So the V is given. How can we find the lambda? So that means delta L is equal m lambda. The lowest frequency to have a constructive interference when m will be equal to 1, correct? So that means delta L is equal to the lambda. Now how can we find the delta L? The delta L itself is equal to the L2 minus L1. So let's say this is L1, so L2 will be this distance, okay? So the L2 is equal to the L1 squared plus D squared, okay? So you have to find L2. The L2 will be equal to L1 is equal to what here? 3.11 squared plus 5.51 squared. Now if you do calculation, the L2 should be equal to 3.217 meters, okay? Then for the part A, what we have so delta L is equal to the L2. Then we have to find delta L. Delta L is equal to the L2 minus L1. I made a mistake. I made a mistake here. L2 itself should be equal to the 6.33. Now the delta L will be equal to the 6.33 L2 minus L1, which is 3.11. That should give you the 3.217 meters, okay? So in the part A, what we have delta L is equal to the lambda, okay? Because it says that the lowest frequency for which there is a maximum signal due to the constructive interference. So therefore lambda itself now will be 3.217 meters, and then frequency lowest will be V over lambda. So now V is here is equal 343 divided by 3.217. Okay, this is the part A. Now what about the part B? So now what about the part B? In the part B, it says that what is the second lowest frequency for which there is a maximum signal? Now the second lowest frequency to have a maximum signal due to the constructive interference, because maximum signal means constructive interference. For that one, what we have, again, we use delta L equal to the m lambda. This is formula for constructive interference. For the second lowest frequency, now we have to put into m the number 2, because initially we put 1. Now the second lowest will be when m is equal to 2. Okay, and so on. From then you have to find again the second lowest frequency. Okay, now what is next? In the next one, in the part B, now part C. In part C, we have to find what is the lowest frequency for which there is a minimum signal due to destructive interference. Now we have to find the lowest frequency due to the minimum signal due to destructive interference. Okay, for destructive interference, we have to use the second equation. The second equation is this one. Okay, so that means delta L is equal to the so instead of m plus 1 over 2 lambda. Okay, so the minimum or lowest frequency when there is a minimum signal to destructive interference, we have to put into m 0. Okay, so that means we'll end up with 1 over 2 lambda. So delta L is always there. You don't need to recalculate again and again. That means 6 point. Okay, not this one. Sorry, guys. Delta L is which one? Yeah, delta L is here. So that means 3.217 is equal 1 over 2 lambda. From there you have to find the lambda. Once you find the lambda, you have to use this equation. Frequency is equal V over lambda. Okay, then what is left? Then what is the second lowest frequency for which there is a minimum signal? Okay, for that one, again, there is a condition for destructive interference. That means delta L, this is a part T. Okay, delta L is equal to the m plus 1 over 2 lambda. Now this time we have to put the into m number 1. Okay, then you should get the right answer.